Let us visualize graph of ellipse and hyperbola through their equations. This is the general equation of an ellipse centered at origin. Okay, and A and B are semi-minor and the major axis. I will not add respectively here because which one is the semi-major axis, that is decided by the values of A and B. Okay, uh, as we increase the value of A, you'll see the semi-major axis is, or the major axis of the ellipse is along x-axis. If we increase the value of B, means if B is greater than A, then the semi-major axis is along y-axis. So this is how we can visualize the equation of ellipse by comparing the values of A and B. So once you able to visualize the ellipse, then you can easily decide your focal points, means the two foci, the two vertices, and all rest terms related to the ellipse. Okay, so if B is greater, then y-axis is the major axis. If A is greater, then x-axis is the major axis. So you got to know how to analyze the equation of an ellipse. Okay, if A is equals to B, then we do not have major axis, we do not have minor axis because they are same. And in that case, we have a circle because semi-minor axis and semi-major axis are equal. Okay, so this is, then it becomes a circle. So you can say all ellipses are circles if semi-minor axis is equals to major axis. Means if the measures of the two axes are same. Okay, you can visualize it from here also. This is the general equation of all the circles in anywhere in the Cartesian plane because H and K are here. No, so these are the circle can be anywhere, can have any center and any radius. So it represents the general equation of all the circles. But if H and K are 0, the equation reduces to x square plus y square equals r square. And what is that? That is the general equation of the circles centered at origin. So this represents infinitely many circles, and then when h and k are 0, then equation becomes x square plus y square equals r square. That also represents infinitely many circles, but the infinity of both the sets is different. The later one has the infinity lesser than the previous one. So here, so when the equation reduces to x square plus y square equals r square, this can be rearranged to x square over r square plus y square over r square equals to 1, which is very similar to equation of ellipse. And as the denominator is r square in both the terms, that means A is equals to B. Okay, so that's why all circles are special cases of ellipses. The special cases where A is equals to B. Okay. Now let's see here this equation of ellipse. A is not equals to B, so it's not a circle but an ellipse. And which one is gonna be the semi-major axis? Means will this ellipse be elongated along x-axis or y-axis? Here we can see as 17 is greater than 4, therefore the ellipse is gonna have major axis along y-axis. Let's see. Sorry, not this one. So ellipse has the major axis along y-axis. Here this is 25 is greater than 6, therefore the major axis is along x-axis. You can see this is there. Okay, so now you are able to visualize the equation of ellipse. Now let's focus on the equation of hyperbola. This is the equation of hyperbola. This minus sign is indicating that. Okay. So this is the thing. Now the equation of ellipse was visualized by comparing the values of a and b. Let's see here. If I increase b, what happened? This axis, this is called, we do not have the concept of minor and major in the hyperbola, but we have transverse and conjugate axis. Okay, so this one is called transverse axis and this is called conjugate axis. So transverse axis is along x-axis when b is greater than a. But if I increase a, transverse axis is still along x-axis. Okay, you can see that. If b is greater than a, still transverse axis is x-axis. If b is less than a, still it is. So we cannot visualize hyperbola by comparing the values of a and b. Okay, rather we have something different. And what is that? The sign. If this sign is with second term, that means the transverse axis is always along x-axis if if this term is positive. But if this term is positive and this one is negative, then it gets inverted. Okay, let's see. This is your y-axis and this is your x-axis. Okay, sorry. So here you can see. Now x square term is negative and y term is positive. So the transverse axis is along y-axis. So equation of hyperbola is analyzed through the sign of the term. There are two terms, first and the second term. Okay. So the transverse axis is along y. If y is positive, it will be along x if x is positive. It is not analyzed by comparing the value of a and b. Okay. Let's go back. So here, this is your ellipse, this is your hyperbola. So when a is less than b, so the semi-major axis is along this, but no effect on the transverse axis. Okay, and when b is less than a, means a is greater, then the semi-major axis is along x-axis, but the transverse axis is still on the x-axis only. So I suppose now that gave you an insight to look at the graphs of hyperbola and ellipse through their equations. That's all for this video. Thank you.